Good evening, everyone. So let's begin our discussion in motion in a straight line and then move on to motion in a plane. Okay, students. So we had discussed some of the basics with regard to motion in a straight line. We have discussed about terms such as displacement, velocity, acceleration, correct? Now, tell me, what is displacement? How are velocity and displacement related to each other? Velocity, rate of change of?
Displacement to time.
Yes. Rate of change of displacement with respect to time. And how is acceleration related to velocity?
Rate of change of velocity by time.
Yes, rate of change of velocity with respect to time. So I can write it as dv by dt. All right. So if I have velocity time graph, then acceleration will represent the slope of the tangent, correct? Now, if I rearrange this equation and write displacement in terms of velocity, then we will get ds is equal to v dt, and s can be written as what? Integration of velocity dt. Correct, students?
Yes, sir.
Yeah, similarly, the other equation, if I keep dv on one side, then I will get a dt. When I integrate, I'm going to get what? Velocity is equal to integration of a dt. You have clearly seen what is the geometrical meaning of integration, students?
So curve of area under the curve.
Excellent. Very good. So whenever we talk about integration, it is the area. For example, if I'm integrating area, then to find velocity, what I need to do is simply look at the graph, find the area under the graph and x-axis. All right, excellent. Of course, when I'm going to differentiate it, geometrically it means what? Slope of tangent. So whatever point I'm interested in, I'll draw a tangent at that point and then find the slope at that point. Are these concepts clear, students?
Yes, sir.
Very good. Now let's just quickly review the questions which we discussed. I think first 4 questions are discussed, but still, we'll review them quickly. So what graph is given here, students?
Velocity time graph.
Velocity time graph. And here we are interested in finding distance. So in this case, no problem whether we are asked distance or displacement. From the graph, we will be able to tell one aspect, that as long as the particle is moving in a straight line, distance and displacement are going to be equal because the body is not changing direction. How do we know that the body is not changing direction, students? Is it possible to tell from the graph whether the body is not changing direction? And if so, how? What indicates? What graph is this? This is velocity time graph.
Sir, if the graph is containing negative, then the particle will change direction.
Excellent. Fantastic. Okay, that's perfect. So when I look at the graph, if the graph of velocity goes below the time axis, then velocity is negative, isn't it? If velocity is negative, it means that the direction which is started, you take it as positive. And when it is negative, it means the body has come back, or it is turning back. The velocity is in the opposite direction. In that case, distance and displacement will be different from each other because the body has changed direction. Here it's very clear that the body's velocity has become 0 at some point, but it never changed direction. That is very evident, that because the velocity does not go below the time axis. Excellent answer. Okay, so now we need to find displacement from velocity time graph. So I need to look into this, isn't it? I am given velocity time graph. I have to find displacement. Basically, what do I need to do? I need to integrate, correct? But integration is same as finding what?
Area.
Area. That's it. Therefore, it is enough if I find the area under this graph. That's it. Correct, students? As simple as that. So you just have two triangles and you need to find the area under them to get the answer. That's it. So one triangle, half base into height. So the required answer, required displacement is nothing but half base into height, which is base is 0 to 4, which is 4 into height. What is height, students?
8, sir.
8. Excellent. So this gives me the area of the first triangle. Now there's the next triangle. We'll find the area plus half. What is the base, students?
4.
2 in this case. Multiplied by what is the height?
8.
8. Okay. So the answer for displacement is 16 plus 8. That gives us what? 24 meters.
Excuse me, sir. It's distance in the first 4 seconds. So I guess the next.
Thank you so much, Evelyn. Thank you so much. I think this is exactly what I did in the class as well. Dear students, thank you so much, Evelyn. So please read the question carefully, students. It is only in the first 4 seconds. Therefore, our answer will stop at 16. Therefore, it is B is the right answer. Yes. Thank you. Thank you so much. So this is the second part will not be part of the answer. Suppose if we are given for the entire duration of the journey, then you take from 0 to 6, which means you add the second area also. Thank you very much. Is that clear, students?
Yes,
Yes,
sir.
sir.
Excellent. Okay. We'll move on to the next question. Okay. I think it's visible, students.
Yeah, sir.
Figure shows the distance time graph of motion of the car. It follows from the graph that the car is at rest, in uniform motion, in non-uniform accelerated motion, or uniform accelerated motion. What is the right answer, students?
Sir, uniform accelerated.
Exactly, uniform accelerated motion. So, 2 ways of getting to the answer. First way is diagram. Of course, this equation refers to parabola. Okay. T square, whenever x is related to t square, quadratic, right? Then it is a parabolic curve, right? I've told you one idea. Whenever we differentiate a parabolic curve, what answer are we going to get? We are going to get a straight line inclined to time axis. And whenever I'm going to differentiate a graph which is a straight line which is inclined to time axis, I'm going to get a line parallel to time axis. Is that clear, students?
Yes, sir.
Now, whenever we do differentiation. So if you see, this refers to displacement or distance time graph. In this case, we could take this as distance or displacement. When I differentiate this, I'm going to get what? Speed or velocity. And when I differentiate that, I get what? So if you see, how is the acceleration time graph? Isn't the acceleration constant? Although time is changing, the y value is not changing. Is that clear, students? Therefore, the right answer is 4th option. Another way of doing it is by differentiation. So your x is 1.2 t square. How do you get velocity? By differentiating this. 1.2 is a constant. When you differentiate t square, what do you get?
2t.
2t, excellent. So 1.2 into 2t will be 2.4t. So that's your velocity. Now we need to find acceleration. What is acceleration going to be?
T is equal to ds by dt. So I have taken,
Acceleration.
yeah, dv by dt.
Yeah, when I differentiate 2.4t, what am I going to get?
2.4.
Yeah, which is constant, isn't it? Therefore, acceleration is constant, therefore it represents uniformly accelerated motion. Is that clear, students?
Yes, sir.
Yes. Okay, let's look at the next question. Are you able to see the question?
Yes, sir.
Yes. A body
Yes,
is
sir.
moving along a straight line path with constant velocity. At an instant of time, the distance traveled by it is s and the displacement is d. Then which of the following is true? Moving along a straight path with constant velocity, which means the velocity is not changing. Neither in direction nor in magnitude. Because we know that velocity is a vector quantity. So when I say the velocity is constant, it means the magnitude of the velocity is also constant. Direction is also constant, which means it doesn't change the direction. Correct? So when it doesn't change the direction and it's moving along a straight line, what have we seen, students? It is moving in a straight line path with constant velocity, same velocity. Then displacement and distances are
Equal.
equal. Exactly. That's it. Simple.
Yes, sir.
Suppose the body is going to change direction, then what can you say about distance and displacement?
Velocity.
Come on, ma. I'll repeat my question. My question is, if the body is moving with velocity, same magnitude, but then direction is changing. That means it is turning back. Then what can you? How is distance and displacement related? Which is greater? Are they going to be equal?
No, sir. Distance will be greater.
Distance will be greater than displacement. Okay. Now we'll move on to the next question. This. Okay. A body moving is moving in a straight line, as shown in velocity time graph. The displacement and distance traveled by the body in 8 seconds are respectively. So good guys. Now we'll take care of how much is asked. So in 8 seconds, and if you look at the diagram also, we have from 0 to 8. Fine. So we have to take the complete diagram into account. Number 1. Number 2. Body is moving in a straight line. Correct? It's moving in a straight line. But what do we understand from this velocity time graph, students? Can you tell me? Let's do a little analysis of this graph. From 0 till 2, the velocity is constant, positive. That means it is moving in one particular direction. Then from 2 to 4, it is having a negative value, which means, what does it mean, guys?
Changing direction.
It is changing the direction and moving with the constant velocity in the opposite direction. Then after 4 seconds, 4 to 8 seconds, it is once again changing the direction and moving in the original direction which it started, right? So are you able to understand this?
Yes, sir.
Good. Now next thing is, we are supposed to find two things here. We're supposed to find the displacement and we're supposed to find the distance. Okay. Now as we have seen, displacement is given by integration of v dt. which I have told you, it is the area under the curve. Area under the velocity time graph. Is that clear, guys?
Yes, sir.
Yes. So all that I need to do is find this area, find this area, and find this area. These three will be giving me the distances in those directions. All right. Now, the displacement find, if I'm talking about displacement, right? Then I can say the displacement here will be positive. The displacement that I'm going to find here will be positive. And the displacement that I'm going to find here will be what? Negative, because it is in the which direction? It's in the opposite direction. Clear? So let us write down, first let's find out the areas, three areas, students. So displacement is equal to area 1 plus area 2 plus area 3. Area 1 will be just a rectangle length into breadth. So you can see this distance is 4, whereas this is 2. So it is 4 into 2. And area 2, if you see, it's a square. This distance is 2 and this distance is also 2. So it's going to be 2 into 2 plus area, the third area is going to be again a rectangle 4 into 2, correct? So as I had told you earlier, what am I going to get? What is the sign of the second area that I have written here? It's minus because it is below the time axis. Clear, students? So if you want, you can write this as negative when you're talking about displacement. If you do integration, then integration will automatically take care of that negative sign. You just have to integrate from 0 to 8. While you integrate, the negative sign will automatically be taken care. You don't have to separately do it. 8 minus 4 plus 8. 16 minus 4, so that's 12. So 12 meters is going to be your displacement, right? So right away you can understand either the answer is A option or it has to be C option, correct? So far clear, students?
Yes, sir.
Yes. Now let's look at the displacement, or sorry, distance. So the only difference will be, whatever you wrote negative here, it's not going to be negative. When I say distance, there is nothing called minus 4 meters. Is that clear? So whatever direction it is moving, you are simply going to keep on adding that, right? So 8 plus 4 plus 8. So whether it moves forward or backward, doesn't matter. Distance is going to keep on increasing. You're going to add all of them. So 8 plus 4, 12, 12 plus 8, 20 meters. Therefore, the right answer is 12 meters and 20 meters. Displacement is 12 meters and distance is 20 meters. Any doubts, students?
No, sir.
Sir.
Excellent. Now we'll move on. We move on to the next question. Can you try this, students, on your own and share what would be the answer? This, you must have solved questions like these in your NCERT. Can you try now? I'll give you a minute. Okay, let's discuss this question now. A student is standing at a distance of 50 meters from a bus. So there is a bus. And our student is standing at what distance, students?
50 meters.
50 meters.
Yes, 50 meters from the bus. As soon as the bus begins to move with an acceleration of what? What is it moving? How is it moving?
1 meter per second.
Square. Acceleration. Yes, yes. So it's moving with an acceleration of 1 meter per second square. Immediately the student is starting to run. with a uniform velocity. He is not accelerating. He is running with a uniform velocity. At every instant, he is maintaining the same velocity. All right. Assume the motion to be along the straight road. What is the minimum value of u so that the student can catch the bus? That's all. Okay. Now, minimum value of u. Okay, how much must be the minimum speed so that he can catch the bus? Of course, if he goes at a greater pace than that, definitely he'll be able to catch the bus much faster. But if he does not maintain some minimum velocity, he'll never be able to catch the bus. Do you agree, guys?
Yes, sir.
Yes, sir.
Yes. So what is that minimum value is asked? For finding the minimum value, you need some extra information I'll share with you. But till that point is quite simple. Okay. So first, let's write it down. So what is the velocity with which the boy is traveling? Yes, students?
U.
U. Yes. So now let us take in time t, he is able to catch the bus. Let the student catch the bus after t seconds. Okay, students? So can you tell me in those t seconds, how much would have been his displacement? Could you tell me?
50 meters.
Yes, his displacement would have been 50 meters. That difference he must have captured, isn't it? But it is not necessarily 50. Could you tell me why? Anybody can tell me why it
This
is?
is moving.
Sorry?
Because the bus is moving, sir.
Very good, very good. So bus has also moved, correct? So let us say the bus has moved, right? That displacement is SB. Let's say this is the displacement, the bus has moved. Then how much he should have moved, guys? Let's say the door is, okay, let's consider the bus to be a point object, not with some length, okay, at this point in time. Or the length is insignificant compared to the distance they travel, let us say. So he has to reach the bus, isn't it? Exactly. So why is it not 50? I think, did you understand? I think Jerome had answered. Who had answered? It is 50 meters.
Me, sir.
Yeah, tell me, Jerome. So why is it not 50? Did you understand?
Yes, sir.
Because in the same time, the bus is not stationary, right? It is also moving, correct?
Yes, sir.
Okay, so let's say in the same time t, bus has moved a displacement SB. Then how much should the student move? If suppose in the same time he also moves SB, what will be the difference in the distance between both of them? I repeat, let's say from the time when we are considering that the distance between them is 50 meters. Now in t seconds, let's say the bus moves another 50 meters. If the student is also moving another 50 meters, the distance between them will be still 50 meters, correct or not? So what is the conclusion? Student must move greater distance in the same time than the bus or equal distance? Tell me. Or less distance?
Equal distance, sir.
If he moves equal distance as the bus, right? That's what I'm telling. Say a bus is here, student is here. What is the distance between them? 50 meters. Okay.
Yes, sir.
Now, if the bus moves, bus is also moving, right? Both are moving, right? If bus moves 20 meters, student also moves 20 meters, what will be the distance between them? Once again, 50 meters, correct or not?
Yes, sir.
So, if the bus moves 20 meters in some time, in the same time, student moves how much to reach the bus? Are you able to understand, students? Very, very simple concept. Come on. Everybody, listen now. Bus is here, student is here, 50 meters is the distance between them. Are you able to see my video or you're looking at just the page? I'm showing something in my hand with my hands. Are you able to see?
Yes,
Yeah,
sir.
sir.
Yes, sir.
Yeah. Now just observe me carefully. So this is the distance. Okay, how much is the distance? This is the bus. This is the boy. Now,
50
what-
meters.
50 meters. Now, if the bus moves 30 meters in another 5 seconds, let's say, the boy should move more than 30 meters or equal to 30 meters or less than 30 meters to catch the bus.
More than 30 meters.
Absolutely, more than 30 meters for sure, correct? How much he should move?
50 plus 30.
50 plus 30, exactly. So he must, so bus is moving 30 meters. This guy has to move not only that 30, but also the difference between the distance 50. So he must move 80 meters in that same duration of time to catch the bus. Yes or no?
Yes, sir.
Good. All right, guys. Suppose distance is 50 meters. Bus has moved 10 meters. Now, how much should the boy move to catch the bus in the same time?
50 plus 10.
50 plus 10, 60 meters. Correct. Excellent. Okay, got it right. Okay, now. So now tell me, guys. So S1 is the distance moved by the student. SB is what? The distance moved by the bus in the same time. Plus, how much should he cover to catch the bus?
50.
50. That's. Are you all on the same page now? Are you all clear?
Yes, sir.
Yes, sir.
Okay, now let's move on. So, how much will the boy cover? What is this? What is this displacement given by? What is the formula for displacement, guys? What is the formula for displacement?
UT plus half 80 square.
80 square.
Yes. Now, so what is this velocity? U. What is the time during which he is traveling? T. What is his acceleration, guys?
1 meter.
Hello, look at this. Bus is traveling with what, ma?
Acceleration of 1 meter.
1 meter per second. What about the boy?
Uniform velocity.
Uniform velocity means what is his acceleration? Come on.
0.
Constant.
Zero.
Yes,
Uniform
that is
velocity
the-
means constant velocity. That means no acceleration. So he is not accelerating at all. Are you able to understand? Are you getting the point? What is the velocity which is running?
Yes, sir.
Yes, sir.
So he will cover distance of UT. Are you clear with that, guys?
Yes.
Yes.
Okay, good, done. Now, what will be the displacement of the bus? Come on, tell me, guys. What will be the displacement of the bus? Come on, displacement, same equation. Tell me.
Equal to UT plus half 80 square.
UT plus
because
half
it
80 square. Does the bus have an initial velocity?
is 0. 0.
Zero, right? Because it begins. So which means the displacement of the bus, if I write the equation, right? Once again, the formula is UT plus half 80 square, but U is what?
0.
0.
But there is only acceleration. So bus is traveling with an acceleration. Now you substitute guys. So what is A?
1.
1. Okay. Are you clear, guys?
Yes,
Yeah.
sir.
Okay, so displacement of the bus is half t square in the same time t, but he should not be traveling at half t square, but he should be traveling a distance of half t square plus what?
50.
50.
In order to catch the bus. Is that clear, students?
Yes, sir.
Yes, sir.
Excellent. Now let's do one thing. Let's write u in terms of t. So take the t to the other side. So what is u equal to? Come on, t square by 2 divided by t. I'm asking you to. take this t down to the other side. So what will it be? T square by 2t. Come on, tell me, guys.
T by 2.
Yeah. Then what about the next term? 50 is also divided by t. So what will you get? 50 by 2. Clear, guys?
Yes, sir.
So this is the equation I was expecting you to get. No problem. Does not matter. So are you clear?
Yes, sir.
Yes,
So
sir.
till here is straightforward. Now, we are supposed to find u, but t is not known. Correct or not?
Yes, sir.
Okay. Now multiple values of u is possible. But we are interested only in the minimum value of u so that he is able to catch the bus. All right. Okay, everybody have you taken down till here?
Yes, sir.
Value of t
Yeah,
is
sir.
the answer.
Clear? Any doubts? Any doubts till here? Till u is equal to t by 2 plus 50 by t. Any doubts?
No, sir.
No, sir.
Okay, excellent. Now we are going to get into something which is new for you. Okay, to answer this final part of the question. Okay, what is it? We are not. See here, we are only given, we are having one equation, right? But then two unknown variables. 2 is also known as t is also unknown, correct? But one thing is asked that we are not required to find out different velocities. We are required to find out only the minimum velocity. Okay, for this little bit of analysis of the graph we will do. Okay, students. Now, everybody with me on the graph. Let's say a function y is equal to f of x. The graph of a function y is equal to f of x. Okay. Now, if I am drawing a tangent and finding the slope, what is the meaning of that? Tell me, guys. If I am drawing a tangent, it makes an angle theta. I'm finding tan theta. What am I finding?
Slope, sir.
Slope I'm finding, correct? And what is the expression? What is slope? What does slope give you? Slope of the tangent gives you. Quick.
Differentiation.
Fantastic. dy by dx. So dy by dx, let's say the point is 1. Let's say, let me call this point as 1. Gives you the slope of the tangent, correct? Tan theta 1. Okay. Now, let's say I'm choosing another. Now, can you tell me the value of dy by dx? Is it positive or is it negative or is it 0? Can you tell me? At whatever point I've drawn. Can you tell me what is my dy by dx, students? Use a little bit of trigonometry. See what is theta 1. Theta 1, what angle is it making? And tell me, guys.
Sir, it's negative.
Exactly, Ma. Exactly. Right? Because theta 1 is obtuse. Is it obtuse or acute, guys? This angle.
Obtuse, sir.
Obtuse is more than 90. More than 90 means it's from 90 to 180, which means the angle is in which quadrant? First quadrant, second, third, or fourth? Obtuse angle. More than 90. Second quadrant. And from ASTC rule, you know that second quadrant tan theta is positive or negative, guys? First quadrant, all trigonometric ratios are positive. Second quadrant, only sine and its reciprocal are positive. Third
So it
quadrant,
will be negative.
tan is negative. Yes. In the second quadrant, tan is negative. Therefore, you will get a minus negative answer for this. Is it clear, students? Are you clear with this?
Yes, sir.
Yes.
Let me talk about another point. Let's say that, let me call that point as 2. Let's say I draw a tangent at this point. Let's say I'm finding out the angle it makes with x-axis, let it be theta 2. Now, can you tell me, what am I doing now? I'm drawing a tangent, finding the slope. So what am I getting? What am I getting, students?
dy by dx.
Dy by dx at the point 2, which means what? Which is nothing but what? Which is nothing but the slope of the tangent. And according, we know how to find the slope of the tangent if a line is making an angle, right? What is it? Tan theta. So now it is tan theta 2, correct?
Yes, sir.
Okay. If you're wondering how it is tan theta, because slope is measured by change in y by change in x. Okay. So this is theta, opposite by adjacent. That's why it is tan. All right. Greater the y for a small x, slope is very large. Small y, greater x, then slope is very low. Okay, anyways. So now dy by dx is tan theta 2. Now is theta 2 acute or obtuse?
Acute, sir.
Acute, right? So what can you tell me about the sign of tan?
Positive.
Positive, yes. See, you wouldn't be spending this much time on the question once you know all these concepts. You will do it like this, okay? Once you know these concepts, because I'm teaching you these concepts, you're learning them, right? All right, but once you've learned them, no problem. I'll tell you, you'll be able to do it instantly after that point, okay? Okay, guys. Now I am asking you a important question. At this point, I'm drawing a tangent. What angle is this line going to make with x-axis? Let me call this theta 3.
0.
0, obviously, right? It is parallel to x-axis. So what is the slope of this line?
0.
0, exactly. Zero. Are you clear, students?
Yes, sir.
Yes, excellent. Okay. Now, from by seeing it, can you tell me, is it a minimum point or a maximum point? In this graph, if you see, is this a minimum point, minimum value point, or maximum value point?
Minimum, sir.
Minimum, right? That means compared to its nearby points, the point is lower, correct? So you have, this is a minimum point. So using this logic, we are going to solve this sum. So to find the minimum of any function, what I should do, I'll tell you. First thing that you can understand is, if a function is reaching minimum, then what will be the first derivative? What is dy by dx? What have we got dy by dx as?
Tan theta.
Tan theta, right? If this point, I'm talking only about this point now. What is my tan theta? Come on.
Negative.
Not negative, guys. I'm talking about this point. This point. This point which is at the center here, minimum point. At that point, I'm drawing a tangent. Tangent, how is it?
Right.
Straight line parallel to x-axis, time axis. So, what is tan theta? What is theta? Just now you answered.
0.
Tan 0 is 0. So dy by dx is 0. So when a function reaches minimum point, at that minimum point, what will be the slope? Tell me. How to find the slope? Draw a tangent. How to find slope? What is the angle it makes with the x-axis? What is the angle it makes, ma? 0. So what is the slope?
0.
Tan 0. So how much is the answer?
0.
0. And what is slope? So do you understand this? This is what I'm trying to say. If a function reaches minimum, at that point, if you draw the tangent and find its slope, slope is 0. Are you clear? I would like to get a thumbs up from those who have understood. Yes, yes. Calvin, I'm not getting a response. Aditya, yes, Aditya has responded. Hrithwik has not responded. Okay. Hrithwik understood. Okay. If not, don't worry. Okay, I'll explain again. Okay. So let me explain once more what I said quickly. Very simple, guys. So you have X, you have Y. If I draw a graph, what is this point called? In this graph, what is this point? Is it called minimum or maximum?
Minimum, sir.
Minimum. All that I'm saying is, only one thing I'm saying, at this point, the slope is 0. Is it true or not? Because what is slope? Dy by dx. And how do I find it? Tan theta. What is my theta? The angle that the pink line makes with the black line here. Horizontal black line. So what is it? They're parallel, which means angle is 0. Yes or no?
Yes, sir.
That's all that I'm saying. So if I get a point which is minimum, then dy by dx will be what? If there is a function which reaches minimum at a particular point, minimum means lowest value at a particular point. At that point, what will be my dy by dx? It's in front of you.
0.
0. Okay. Clear, not clear, guys?
Yes, sir.
Yes, sir.
Okay. Now tell me, guys. Now, can you tell me what is this point?
Maximum.
Maximum. Wonderful. Who answered that?
Hrithwik, sir.
Hrithwik. Good, Hrithwik. Okay. This is called maximum. Why is it called maximum? Because that value is, y value is higher than the neighboring values. Agreed or not?
Yes, sir.
Okay. Now my $1 billion question. What will be dy by dx at this point?
Sir, is it 0?
Who is that, ma?
Sir, Amog.
Huh? Amo, very good, Amo. Excellent, excellent. I'll give you a chocolate when I meet you. Okay, can you tell me, explain, Amo, how it is 0?
Sir, because even the angle is 0 and
Exactly.
the slope
First of
also
all, dy
will
by
be 0.
dx means slope of the tangent. That means, first of all, I draw a tangent. And tangent, how much angle it makes, Amo?
0, sir.
0 with x-axis. Very good, excellent. So dy by dx is 0 here also. So first condition for a point to be minimum is what, guys? What is the first condition for a function to be minimum? Dy by dx is equal to
0.
0. What is the first condition for a point to be a function to be maximum at a particular point? That's also in front of you. Amog has answered now.
0.
0. So whether a function is reaching maximum or minimum, dy by dx will be what?
0.
0 at that point. Excellent. Okay. Now let's do the next step. Okay. For that, the other diagram will be required. So one condition is not enough. Second condition is also required. Okay. Let me now take you through this graph. I was drawing this graph. Correct. Now pay close attention to this. So clearly at the point where black ink is there, what is the slope? Quick.
0.
0.
0.
dy by dx is 0. Correct. Okay. Number 1. Number 2. But if I say dy by dx is 0, can you be sure that it is a minimum point?
Nope.
No, excellent. It can also be what? Come
The
on.
maximum.
Maximum point. Excellent. Excellent. Okay. Now, how do you be sure that it is the minimum point? So, necessary condition is that first derivative is 0. Now, second derivative will give you information about whether it is minimum or maximum. Let me tell you now. I'll go back to this diagram and then here itself I'll share with you with different colors, because this concept is going to come with you several times in physics days. So you need to be thorough with this, especially those who have all of your writing, preparing for competitive exams is a favorite concept for teachers to ask. So that's why it's important that you spend enough time, learn this concept. Once you've learned, you can, it's a piece of cake. Okay, fine. Now tell me, Ma, quickly, please pay same amount of attention that you have paid, whoever has attentively listened to this. Okay, now let's look at minimum now. Before this point, what is dy by dx?
Negative.
Awesome. It is negative because if I draw a tangent here, what angle it will make, guys, with x-axis?
Obtuse.
Obtuse angle. So tan of that angle will be what? Negative. Okay. Now, beyond this point, what will be dy by dx, students?
Positive.
Positive. Excellent. Because if I draw a tangent at that point, that tangent will make acute angle and tan theta will be positive. Fantastic. So, if dy by dx is going to change sign around that point from being positive to negative, I'm sorry, from being negative to positive, isn't it? First is what? What is this? Here, what is dy by dx? Negative. Why?
Negative.
Tangent makes obtuse angle. Here, what is y? Now, dy by dx.
Why it is
So, dy by dx is what? Here. Positive, correct?
Yes.
Yeah. So, if dy by dx changes sign from negative to positive, then the point that we are talking about is what?
Minimum.
Minimum. Very good. Now, let's do the same thing here, guys. At this point, can you comment on what is dy by dx, positive or negative? Jaldi. At this point on the curve. Okay, tell me, start from here. At this point, what is dy by dx?
0.
At this point, it is 0. Now tell me, what is it at this point? How to find out? Draw a tangent, see if it's making acute or obtuse angle. Come on, tell me.
Obtuse, sir.
Obtuse, huh?
Acute.
What angle it makes?
An acute angle.
Acute angle. Therefore, good. Therefore, tan theta will be what? Positive or negative?
Positive.
Positive, or in other words, dy by dx will be what? Dy by dx is positive. Dy by dx is tan theta, correct or not?
Yes, sir.
Yes, sir.
What is dy by dx here? 0, right at the topmost point. Dy by dx means slope of the tangent, correct or not?
Yes, sir.
Okay, good. Very good. You're doing well. Now, last. At this point, if I draw a tangent, to draw a tangent at this point, what angle does it make with x-axis here?
Obtuse.
Obtuse angle. So, obtuse angle, tan of obtuse angle is what?
Negative.
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 dy by dx is?
Negative.
Okay, now let me summarize. If dy by dx changes sign from positive to negative around that point, then that point is the maximum point. Can I say that? Before dy by dx becoming 0, it was positive. After dy by dx became 0, it became negative. Then What is that point where it becomes 0? Is it maximum or minimum?
Maximum.
Maximum.
That's all I'm trying to drive. So dy by dx changes sign positive to negative. Then what point are we talking about? Maximum point. On the other hand, if dy by dx changes sign, from what? Come on, tell me.
Minus to plus.
Negative to positive.
Negative to positive. Here dy by dx is negative, here it is positive. Then what is the point we are talking about, guys?
Minimum.
Minimum.
Are you clear now?
Yes, sir.
Yes, sir.
Okay, how do you check? How do you check? Because we don't have the graph. How do you check? We just have the equation, correct? Go back to that question equation. U is equal to some 50 by t plus t by t square by 2, whatever, right? We don't want to be plotting the graph and finding all these, correct or not? Yes or no, guys?
Yes.
sir.
Yes,
So we
sir.
need to understand this and then tell something. So two equations we can tell. First equation, if a function is reaching minimum at a particular point, what are the first conditions, students? First condition. Quick. First condition. Wherever it is reaching minimum, what is the condition?
Angle should be 0.
Very good, very good. So now talk in terms of dy by dx. Correct, correct. Angle should be 0, correct. What does it mean?
It's negative.
Hello, hello.
Slope
Angle
is
is 0. Angle is 0 means slope is tan 0. Tan 0 is 0, correct, Evelyn? So dy by dx must be what?
0.
0. That's what I'm saying. Not negative, not positive. 0. Correct or not? Yeah. So if a function is reaching maximum, what is the first condition? At that point where it is reaching maximum, what is the first condition there?
Should be 0.
What should be 0?
dy by dx.
Excellent, excellent. So first condition is same for both of them. Okay. Yes or no?
Yes.
Yes. Okay. Now I'm interested in the second condition. Whoever is answering this, I'll give you a big chocolate. Okay. Tell in terms of d square y by dx square, students, and explain this. What is d square y by dx square? What is dy by dx? Change in y with respect to x, correct or not?
Yes, sir.
What is d square y by dx square? Change in dy by dx. All right. I repeat. What is dy by dx? Change in y with respect to x, correct or not?
Yes.
What is d square y by dx square? Change in dy by dx with respect to time. Clear?
Yes, sir.
It's the second derivative, that's all. So how do you find the dy by dx, guys? You find change in y. Change in y means what? Final value of y minus initial value of y. Okay, correct or not? And of course, you make delta t to 0 and all that. That's fine. But idea is final value of y minus final value of x. Correct? Now,
Sir, I did not understand, sir.
you are not understanding, Evelyn.
Yes, sir.
Okay, I'll explain. Is the first idea okay for you? Dy by dx equal to 0.
Yes.
Okay for you? Yeah, okay. Now, very simple. Now, let's look at minimum now first. Minimum, if you see, can you tell me dy by dx changes sign from what? Negative to?
Positive.
Is that understood, Evelyn?
Yes, sir.
So, first it was negative, now it is positive, correct?
Yes, sir.
Yes. So, what is the change in dy by dx? Final minus initial. What is the final? Final is what?
Plus.
Final is plus, initial is minus. When you do final minus initial, plus minus of minus, what do you get? Final answer. Let's say, for example, here the slope was -2. Here the slope became +2. Now, what is the change in slope? Final minus initial value.
4.
+4. 2 minus of -2. Correct or not?
Yes, sir.
So your that is nothing but your second derivative. Final value of dy by dx minus initial value of dy by dx with respect to time will be a measure of your second derivative. Are you able to understand?
Yes, sir.
So d square y by dx square will be positive. Did you understand that? Yes, no?
Yes, sir.
Sir.
Okay.
Yes, sir.
Now, when I'm talking about maximum value, what is the final value, dear? Can you tell me, guys, what is the final value? Come on, come on. What is the final value? Am I audible, guys? Hello? Hello? Can you guys hear me?
Yes, sir.
Yeah, I'm asking you. So look at this graph now. Look at this graph now. We are coming to maximum. At this point, what is the value of dy by dx? At the maximum point, what is the value of dy by dx, guys?
0, sir.
0. You are doubtful or you're clear?
Clear, sir.
Clear, right? Beyond that point, what is the value of dy by dx?
Negative.
That's the final value I'm talking about. So final value is negative. Before that point, wherever you draw the tangent, what is the dy by dx value?
Positive.
So final value is negative, initial value is positive. For example, let's say this is -2, this fellow is +2. That is the slope. So you want to look at the change in slope. That is the second derivative. So final slope minus initial slope. So -2 minus of +2. What your answer is? What is your answer?
Minus.
-2.
Not minus, -4, right?
Yes.
-2 minus of final initial value +2. So what is your answer?
-4.
-4, correct or not? I'm not interested in that 4, but I'm asking, you will get a negative number, correct or not? Final value negative. What about the initial value, guys? At this point, it is 0. Beyond it, it is negative. Before that, it is positive. Is it clear for everyone?
Yes, sir.
Yes.
sir.
So in this case, I'm talking this as the final value. So beyond this point, what is the value?
0.
Negative. dy by dx, negative. Before this point, I'm talking it as initial. So what is that?
Positive.
So here you have negative slope. Here you have positive slope. So what is change in slope? Final minus initial value. Final slope minus initial slope. So negative minus positive. What do you get?
Negative.
Negative, that's all. So your d square y by dx square is a measure of change in slope. Your d square y by dx square is a measure of change in slope. Change in dy by dx. So final value negative, initial value positive. Negative minus positive is what?
Negative.
That's it, guys. That's it. Okay, guys. So this, it must get in. So I could have just given this form, but then you wouldn't understand, right? Because this understanding is required. So now tell me, guys, in any question that's given, find the minimum value if it is asked. What do? You do 2 steps. 1 step or 2 steps?
2 step.
2 steps. What is your first step?
dy by dx is equal to 0.
dy by dx is equal to 0. What is your second step?
dx by dx.
Second derivative. Second d square y by dx square. You call it as d square y by dx square. You find the second derivative. You just verify whether you are getting what? Verify if you're getting what?
Positive.
Positive answer or not. If you're getting positive answer, it's the minimum value. Now, if I give you a function, I ask you to find the maximum value. Well, how many steps are there?
2.
2 steps. What is the first step?
dy by dx is equal to 0.
Find dy by dx, equate it to 0. That's your first step. You will get some solution from that. Okay. Now you have to verify that solution. So derivative, do the second derivative. Second derivative must be what? Second derivative must be negative. Then you can ascertain that this function reaches maximum at that point. Is it clear, students?
Yes, sir.
Yes, sir.
Okay. So I will anyway send you the recording of this so that you understand this very clearly. But worst case, if you have not understood, then at least this box you must remember. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Have you made a note of it?
Yes, sir.
Okay, great. Now with this knowledge, we will approach this question. Once you know this is no big deal, okay? Now, what is the equation we have got, students?
U is equal to t by 2 plus 50 by t.
Excellent. Okay, so let's write it now. So what is U equal to?
T by 2 plus 50 by t.
50 by 2. Or in other words, to make it little comfortable, comfortable for us, we'll write this as half t. Plus, can I write this as 50t power minus 1, students? 50 by t, I'm writing it as 50 into t power minus 1. Is it okay? One by t, I'm writing as t power minus 1. Is it okay?
Yes, sir.
Yeah. Clear so far? Is everybody with me, guys?
Yes, sir.
All right, great.
Yes, sir.
Now. We want, this is a function of u and t. We want u to be minimum or maximum?
Minimum.
Okay. So for u to be minimum, can you guys tell me what is the condition or what are the conditions?
So dy by dx should be 0.
Yeah. So here you should tell in terms of u and t. Tell me, ma. Change the variables. Tell me. Or let me simply put it for you. First derivative must be what? Come on, correct. Tell me. It's in front of you guys. For a function to be minimum, what is the
dy
first
by
derivative?
dx should be 0.
Yeah. So instead of dy by dx, here in place of u, what do you have? In place of y, what do you have? See, here, y and x, y is the dependent variable, x is independent, correct or not? This is the equation of u and t. So u is the dependent variable, t is the independent variable. So you are finding what?
du by dt.
That's what I'm asking. Clear, guys?
Yes, sir.
Yes, sir.
Okay. Is this enough or one more condition is there?
One more.
Yeah. What is the condition?
The second derivative, sir.
That's all. Very nice. Who is answering that?
Roshni.
Excellent, Roshni. Very good. So second derivative must be?
D square y by dx square.
Yeah. In this case, how do I write it? Can you try?
D square u by dt square.
Awesome, Roshni. Fantastic. And what should it be?
Positive, sir.
Yes, that's all. I just need to verify if it is positive. That's it. So once I do these two things, I'll be getting my u shortly. Okay, fine. So are you clear, guys? Now for this, you need to remember your differentiation table. I told you. You have your f of x. Then you have your dy by dx, correct? So if I have x, what is the differentiation of x? Come on. Come on.
1, sir.
1, yes. Differentiation of x is 1. What is differentiation of a constant into x?
0.
Constant.
Constant here. See here, constant, if it is separate alone, then the differentiation of constant is 0. If constant is multiplied with x, then what is the differentiation of kx? What is the differentiation of 5x?
5.
5. So differentiation of kx.
A.
A.
Okay.
Okay.
Are you clear now?
Yes, sir.
Differentiation of kx is not 0. Okay, fine. Now, next thing that you need to know is what? X power n. What is the differentiation of x power n?
Nx raised to the power of n minus 1.
That's it. That's it. These two things are enough for this. Okay. Now, come on. First step. We are finding du by dt. Come on, tell me. What is the differentiation of half t? Half is a constant. So isn't it like kx? Isn't it like differentiation of kx?
Yes, sir.
What is the differentiation of kx?
Yes, sir.
K. So what is the definition of half t? We have done this several times in the class.
So t by 2.
T by
T by
2.
2.
Half.
Half. That's it. What is the differentiation of 2t, ma?
2.
What is the definition of 5t?
5.
5.
What is the definition of half t?
Half.
Half.
That's it. Okay. Clear?
Yes, sir.
Now 50 into t power minus 1. This 50 is constant in multiplication. Keep it as it is. Okay. Nothing happens to this 50. T power minus 1. What formula will you apply? Come on. What is differentiation of x power n?
Nx raised to n minus 1.
So what is the differentiation of t power minus 1? What is your n here? What is your n?
T.
T is x, huh? T is x. What is your n?
Minus 1.
Minus
So what is the
Minus
answer?
Minus t to the power minus 2.
Sorry?
Minus t to the power minus 2.
Correct. So minus 1 t power minus 1 minus 1. Understood or not? N x power n minus 1. What is n here?
Minus 1.
Yeah. Are you getting it?
Yeah, sir.
Good. Come on. Good. So du by dt differentiation, first differentiation complete. So du by dt, what do you get? 1 by 2 plus into minus
Minus.
Yes.
minus 50 t power, come on,
Minus 2.
Minus.
t power minus 2. Clear?
Yes, sir.
Yes.
Can I write this t power minus 2 as 1 by t square? T power minus 2 in the numerator, bring it to denominator, isn't it t square?
Yes, sir.
Sure.
Very
Yeah.
good.
Minus 1.
Fantastic. We are almost getting the answer now. Okay. So what should I do to du by dt? Come on. What should I be doing to du by dt? For a function to be minimum, first derivative we found. First derivative must be equated to what?
0.
0.
Exactly. So equate this to 0. All right. So 1 by 2 is equal to 50 by t square. So what is t square? How much is t square, students? 100. So
100.
what do you get t?
10.
How much is t? T is 10. Is it enough to ascertain that we got the minimum value of u?
Yes, sir.
Yes, sir.
No, sir.
Only one condition we did, du by dt. Du by dt we equated to 0. What should we verify now?
Second condition.
Second derivative must be for positive. Okay. So I have to differentiate this again. What do you get if you differentiate half? What is half?
It's a constant, sir.
It's a constant. So what is the differentiation, students? When I'm saying d
Zero.
square, don't get frightened by d square u by dt square. It is nothing but differentiation of du by dt. That's it. So when I differentiate half, what do I get, Roshni?
0, sir.
0, right? Yeah. So now what is left? What is left? What is remaining to be differentiated?
Minus 50 by t square.
Yes. So minus 50 by t square. That by t square, how can I write?
Okay.
No. T power minus 2. Please.
Sorry, sir.
T square is in the denominator here. T square is not in the numerator. If it's so, then it will be 2t. All right. So it's minus 50, t power minus 2. Now tell me, what do you do? Minus 50 is a constant, keep it as it is. How do you differentiate t power minus 2? Use this formula. What is it? N x power n minus 1. What is n now?
-2.
Minus 2. So come on, tell me, Jerome. What do you get? We are differentiating this. Keep track.
Minus 2 into t raised to minus 2 minus 1.
Awesome. Excellent. So 0 minus. So it's minus 50 into minus 2 t power. Minus 2 minus 1 is what?
-3.
Awesome. Minus into minus becomes, come on,
Plus.
t into 2 becomes 50 into 2. Come on.
Right.
100 into t power
100.
minus 3. Can I write it in the denominator as t power 3?
Yes, sir.
Yes, sir.
When you substitute t as whatever you got, t as 10, what are you going to get the answer as? Won't you get 1000, guys?
Yes, sir.
So what do you get? 1 by 10. Number is not important. What is important? Are you getting plus or minus?
Plus.
Yes.
Plus
Therefore, definitely, beyond doubt, what is this point? Maximum or minimum?
Maximum. Minimum.
minimum.
Minimum, right? So for a function to be minimum, first derivative 0, second derivative positive. First derivative we equated to 0, we got t as 10, and we got second derivative as positive number. Therefore, certainly this represents minimum value. Now we go back to the function. Okay. All this theory work, just getting to the step. So now telling the answer is no big deal. What is the time? We're not asking about 7:25 p.m. So what is the time we got?
10 seconds.
10 seconds substitute, you will get the minimum value of y, u. So what is it? 10 divided by 2 plus 50 divided by 10, 5 plus another 5. So what is the answer?
Yeah.
So what is the answer to this question? Which option?
C option.
Yes. Did you understand, students?
Yes, sir.
Yes, sir.
Yes. So if he travels at 10 meters per second, this guy will catch the bus. If he travels at any speed higher than that, he will catch it faster. But that's not the question. He will try, if he travels at 12 meters per second or 52 meters per second, obviously he will catch the bus faster. But the question is, what is the minimum velocity with which he will catch the bus? So the minimum velocity he has to run is with a speed of 10 meters per second in order to catch the bus. And in how much time is he catching the bus? Quick.
5 seconds.
10 seconds.
10 seconds.
Yes or no? Great students. Okay. So what did we do? A quick review of what we did now. Come on. The student is traveling with constant velocity, so his displacement is going to be u into t. The bus is not traveling with constant velocity, it is accelerating from rest. The word begins gives you that information. So 0 plus half at square. A is given to be 1 meter per second square. So you write 1 here. So SP is equal to t square by 2, S is equal to ut. And this guy not only should cover the distance of the bus, but he should also cover another extra 50 meters, which is the distance between them. So ut must be equal to half t square plus 50. Till here, very clear to everybody?
Yes, sir.
Yes, sir.
Now we write u in terms of t. So you wrote that like this. Now u has to be minimum, right? For u to be minimum, what are the two conditions? First derivative must be
0.
0. Tangent parallel to x-axis, all this should come into your mind. Second derivative must be
Positive.
positive, all right? Because again, graph must come into your picture. When it's minimum, before that 0, it is obtuse angle. After that, it is acute angle. Obtuse angle, tan theta, negative, dy by x, negative. After the dy by x, positive. So final value of dy by x, positive. Initial value, negative. Final minus initial. Positive minus negative will give you positive. All this must come into your mind. So that, if still deeper question is asked, you are ready to answer. All right. Okay. That's it. So all that you need to do as far as method is concerned is very simple. Once you get here, do two derivatives. First derivative equated to 0. All right. Second derivative should be positive. So that's what we did here. So we took this t by 2 plus 50 by t. By t, I can write as t power minus 1. We differentiate it once using this formula. Equated it to 0. You know that whenever a function reaches minimum or maximum, first derivative will be 0. So you equate it to 0. You got the value of t. Right? In most cases, second derivative will happen. Okay. But anyways, to recheck it, right? So you do second derivative and that gives you a positive value. You don't have to get the exact value unless asked for. Just understanding that it's going to be positive is enough. So you are sure that t equal to 10. When t is equal to 10 seconds, when he catches the bus in 10 seconds, he has traveled with minimum velocity. And how do you find that minimum velocity? Substitute t is equal to 10 here in this equation so that you get the value of u. Initially, because you're learning it for the very, very first time, it may look like a mountain. But trust me, these differentiations, you will do it in a few seconds, guys, with practice. Right? Today, should I tell you what is the differentiation of t square? What is the differentiation of t square? Tell me.
2t, sir.
How fast are you telling? Constant. What is the differentiation?
0.
0. That's the same speed with which you will tell 50t power minus 1 also. That's it. Because negative powers, you have just learned how to differentiate. So you may be taking little time. That's all. Okay. Don't see this as one question. A series of questions which are, going to be based on such concepts. All right. Clear?
Yes, sir.
Excellent. Great. I appreciate each one of you who has been listening. Okay, great, guys. Let's move on. Shall we move on? Anybody is still requiring some time to take down? Should I move to that part of the sheet? Or
Yes,
should we
sir.
go to the next question? Should I go down, guys? Or should I please respond? Or should I give you a couple of minutes to take it down and assimilate? Okay. Now tell me, students. What is displacement of a particle given by y is equal to a plus bt plus ct square minus dt power 4. Can you tell me what are A, B, C, D?
Constant.
Yes, they're all constants. Okay. So now what do we need? We are given the displacement. What is that we need to find?
Initial velocity.
And then later,
Acceleration.
Acceleration.
first, let's find velocity, guys. How is velocity related to displacement?
dv by dt.
dy by dt, correct?
dy by dt.
Okay, now you're differentiating. A is a constant, differentiation of A.
0.
0, good. B into T. B is a constant in multiplication, keep this as it is. What is the differentiation of T? What is the differentiation of X? What is the differentiation of X?
1.
1. What is the definition of T?
T.
Differentiation of T.
Or 1.
Okay, good. C is a constant. T square.
T.
Huh? What is the differentiation of T square?
2T.
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 D is a constant, keep it as it is. What is the differentiation of T power 4? What is the differentiation of X power N? What is the differentiation of T power 4? What is N?
4.
So what is it?
4.
So what is the answer?
40 is cube.
40 cube. Okay. So what did we get now? What have we got? Velocity is obtained. But we are not asked to find velocity. What are we asked to find?
Initial velocity.
What do you mean by initial velocity? Velocity when time t is what? So initial velocity is velocity when time t is 0. All right. Clear, students?
Yes.
So what do we have for the velocity equation? 0 plus b plus, come on, 2ct minus 4d t cube. I'm just rewriting this. Yes.
Yes, sir.
Yes, sir.
So when you substitute t in this equation, what do you get? What are you left with? When you substitute t as 0, what will happen to this term? Two c into 0. What is 2c into 0?
0.
This will be 0. What is d into t cube? What is d into 0 cube? What is 0 cube, dear?
0.
0. Whatever is multiplied will become what? What is 4d into 0?
0.
0.
So this will be 0. This will be 0. Are you clear?
Yes, sir.
So what is the initial velocity going to be? Only this fellow will be there. Yes or no?
Yes, sir.
So what is the initial velocity? Come on, tell me.
B.
B, that's it. Okay. So which could be the right answers? Either A or
C.
correct?
Yes.
Okay, now let's go on. Let's move on. We need to not just find the velocity, but we need to find acceleration also. So let's find acceleration. How do you find acceleration?
dv by dt.
Excellent. So let's do acceleration now. So acceleration is nothing but dv by dt. What is differentiation of, what are you differentiating now? Come on, tell me. What is the differentiation of b? B is a constant. What is the differentiation? Constant differentiation.
0.
Okay. Next, 2CT. What is 2C? What is C?
Constant.
What is 2C?
0.
Don't tell me the answer now. What is C? What is C? Constant. What will it be 2 times of C? That will also be a constant, correct or not?
Yes, sir.
That's all. 2C is a constant. 2C is multiplied with T. 2C is not standing alone. So it is as good as differentiating a 5T. What is differentiation of 5T? What is differentiation of T? What is differentiation of T square?
TU.
Huh? What is differentiation of T square?
Two T.
2T. What is differentiation of T?
1.
1. What is differentiation of 5T?
5.
5.
5.
What is differentiation of any constant into T?
Constant.
What is
Constant.
differentiation of 2C into T?
2C.
2C.
That's all dear. Is it clear?
Yes.
Yes, sir.
Yeah. Okay, now we are differentiating 2CT. So what is the answer?
2C.
2C.
Now next, what are we differentiating?
4dt cube.
4D is a constant in multiplication. Keep it as it is. Differentiate T cube. What do you get?
3T square.
3
T square.
T square. Because it's x power n is nx power. So T cube differentiation is what?
3T square.
Are you clear?
Yes, sir.
Yes, sir.
Okay, good. Fine. Now we are asked to find the initial velocity and initial acceleration. So what is the initial acceleration? That means T, what you must do? This is acceleration. Whatever we got here is acceleration. So what is it? 2C minus 4 into 3 is 12. 12T T square. Clear? 4 into 3, 12. Okay. Now
Yes,
I
sir.
want initial acceleration. Initial acceleration means what I should do?
T is 0.
Excellent. So when I substitute T equal to 0, what will vanish? Yes or no? T is 0. What is 0 square?
0.
0 into D. What is 0 into constant? Students, tell me, ma, what will happen to this term when T is 0? 0 into anything is 0, right?
Yes, sir.
So this is 0. So what will happen? What is the answer?
2C.
Only 2C will be remaining. So what is the initial velocity?
2C.
What is the initial velocity?
2C. B.
Initial velocity is 0. Sorry, B. What is initial acceleration?
2C.
2C.
B and 2C. Which option?
C option.
That's all. Take it down.
Option C.
C is the right answer. Clear?
Yes, sir.
So,
Yeah.
B option.
Second option, Evelyn.
Yes, sir.
Excellent. Can you tell me why first and third are not the options and why second is the right option?
So because if your displacement is final position minus initial, so if you subtract in the first and the third option, will get positive displacement.
Excellent answer, Evelyn. That's it. Final displacement 7, initial displacement minus 8. So change in displacement is nothing but final position minus initial position. So 7 minus 8. you get a positive number. So that's not your answer. Second option, if you see, change in displacement is final position is how much? -3. Your initial position is 7, so you get -10 meters. Third one, final is 3 and the initial is -7. 3 minus or -7 is +10 meter. Therefore, displacement is positive in the first and the third case, negative in the second. Perfect answer. Clear, students?
Yes, sir.
Yes, sir.
Yes, sir.
Fantastic. Excellent, excellent. Very good. Okay, guys, we will stop with this. I will just share a couple of things with you. Have you taken it down? Once you're done with it, let me know. We'll move on. Not with a question, but I just have something to share with you. Okay, students. I hope you are able to see the screen. Everybody?
Yes, sir.
Yes, sir.
Yes, students. Okay, fine. Now, according to you, I'm sure all of you have got phenomenal goals, right? No doubt about it. Now, when you have to attain that goal, when you have to reach that success, right? Process is very, very important, right? You won't get it on day N, isn't it? Tomorrow NEET exam is there. It is not it is just reflecting on that day. All that you have done for 2 years is getting reflected on that day, or CET or JEE, whatever it is, isn't it? But the process is what is most important, isn't it? How you have been going through that process. That's very, very important, students. All right. Success is your end result. Your NEET score or your CET score or JEE score is your end result. Process is what you go through these 2 years, isn't it? Okay. Now, one thing that I want to share with you is you are just coming from school level, right? Now, once you are in school level, right? I'm sure you have been pampered, you have been, taken care very well. Each probably, the teacher did not leave you until you understood a particular question, and maybe there was, a lot of things you understood. So if a teacher teaches something, probably 90-95% of it you understood it, if not 100, right? Now, when you come to college level, plus when you are going through competitive exam training, the expectation and mindset might be same, right? Where if a teacher teaches something, I must be able to understand 95% or 100% in the first go. That's how I have been so far. So that's how I must be, right? But it is not necessarily true, right, students? So because these concepts have raised and are, at a different level altogether, right? So it takes some time for our brain to get tuned to it. So we might not understand at the very first go. Maybe for some of us, it may take 2-3 times of reading plus listening to the, lecture again, so that we are able to understand it perfectly and practice, right? So first step is understanding. That might take some effort. That's the maximum effort, right? Next, equally important effort is your practice, right? I have told the statement to you. This I learned from John C. Maxwell, amazing author, okay, of leadership books, and he conducts a lot of leadership conferences. This guy is magical. So he says this, one of the key things to success is, it's what you learn after you learn it, after you know it all, that counts. So once you've understood, that is the time, I have understood enough, I can write my exam. No, sorry. Once you've understood, that's the starting step. That's the time you will start pressing the accelerator. You may be tired physically, but doesn't matter. That's the time you have to press your accelerator, not to press the brake. All right. That's the time you will practice, redo it. Right. And because you understand it better now you can solve the sums better. So you will solve them, you will get stuck. You will again, try, you will refer to the solution, you will ask the doubts. This is the process. All right. Because you're studying at a different level. I hope you understand that. You're graduating to a different level now. Okay. So that's the second step that is required. And then taking up tests, frequently. So we are going to make our tests frequently and probably shorter. Right. I will talk to you about it tomorrow. So kind of, every day we'll have 15-minute test, 20-minute test on what we discussed earlier. Right. So that will be kind of putting you also on preparation. Everything said and done, we prepare when there is a test, unfortunately, right? But you have to kind of change that attitude. You have to prepare whether there is test or not. I'm sure quite a few of you are doing that. Okay, I appreciate that. So that's extremely important, students. And it is extremely important that we take responsibility. Is that clear? So my goal is very clear. I have to get into NEET. I have to get into CET. Whatever works for me, I have to do it. Is that clear? Everything may not be perfect, so that you must acknowledge it. Maybe difficult, right? I'll take 1 or 2 minutes, students, because it's already 8. I understand you have been sitting for 2 hours after your whatever number of hours of classes. I really appreciate each one of you. I thank you for being here, fully listening to the session. Okay. What I'm here to share with you is, I'll just share a couple of my experiences, right? Number one experience, when I was doing my 12th, right? The maths teacher in my school left in between. Of course, the school was a very normal school where I studied my schooling, did my schooling. It was only advantage was it was closer to my school. Okay. Maths teacher left in between. Physics teacher, chemistry teacher who used to teach me, I used to understand not even anything. Is that clear? Head or tail, I couldn't understand of what they teach, what they used to teach. But anyways, I know, luckily I got a few teachers who could support me in the evenings, right? Who really made me understand everything. I am thankful to them. Even today, whatever I remember is because of these teachers, all right? But I did not go about, just, worrying about and upset about the situation in my school, where maths teacher left in between, physics teacher, chemistry teacher, nothing is getting in, all right? So what did I do? I ramped up myself, right? I took the support of these wonderful teachers who were teaching me in the evenings. I ramped up myself. I prepared. I did a lot of, work, and went to the school. And I used to teach my friends things. And my friends used to say, obviously, right? You teach better than our teachers. So that's when it started, right? Nearly 6 months, we didn't have a maths teacher in 12th standard. Can you imagine? And along with me, one more boy, Karthik. We both used to go to teach for the entire class for a good amount of time. Okay, students. Later, there was one more teacher who came. Again, he just took our help to go ahead with the syllabus in 12th. You can imagine. Okay, anyways. So this was one situation, guys. I secured one of the topmost ranks in Tamil Nadu entrance exam used to have at that time. And then got into engineering in one of the top institutions. All right. And got recruited in one of the topmost companies, Texas Instruments, and later on Intel. All that happened. Okay. But I just wanted to tell you some hurdles in our way and how we handle them. Okay. Second step, college. I entered into one of the best colleges in Tamil Nadu. Okay. Expecting that I'll get something as good as the teachers who taught me in the evenings. All right. This is the #1 college. Okay. I go in there. Teachers come, teach, go. Everything is going above the head, guys. Almost everything except math. Math was fine. There was engineering math. I was master it. I was able to understand what the teacher was telling. Even if she did not teach, that was the kind of enthusiasm I used to practice. It was no big deal for me. But everything else, there was physics, there was chemistry, there was various other subjects. Everything used to go above the head. Right? Despite doing extremely well in physics, chemistry, math, everything in my 12th, all right, and my engineering entrance also. But this was the situation. And there was a subject called electronic devices, which came in the second semester. head or tail, we could not understand from what the teacher was teaching. 90%, this is number one college, guys. Can you imagine? 90% was not entering in to 90% of the, now I can say 100% of the people in the class. Electron device, one thing I'll share and control. I'm sorry to take your time, guys. But just thought, this point, it's important to share. So this teacher, electronic devices, she comes with a book, Milman Halkias. Okay. She says this is the reference book. And whatever she talks in the class is blah, blah, blah. That's it. Nothing gets into our head. Everything, and we are number one students in the state, guys. We are sitting here and everybody is just looking at each other. That's it. We don't understand anything. And she said, this is the reference book. Okay, great. We all buy that book. Foreign edition, it's cost us quite a bit. We bought it. We start going through it. Nothing is understood. We want to read about a concept. This says you go to that chapter, you will understand that chapter, not even in a syllabus, but we have to read. That chapter says go to another chapter previously, that you understand. This was a situation. No, I was like, first semester, first internal test. I'm scoring a 10 out of 30. Okay, 1/3. And entire class is almost in the range or less than that. One guy got 25 out of 30, hostel guy. His name is Harish, I can remember. We all just took, held him and said, how did you manage to get this, guys? Get this. Then he said, okay, I am not referring to Milman case. I am referring to Floyd book from electronic devices from library. Every Floyd is gone by the afternoon. We are going there and, taking it in, correct? It's out of stock. I also took one. I was reading through it. It was much, much, much better than that other book. And then we understood, but not to that extent. I was not satisfied. Then our library is one of the huge libraries in Tamil Nadu, college library. I was not still satisfied. I used to go spend hours together to search for a good book for that one subject. Then I got a book. I remember the name. Way back, guys. I'm telling about story. How many years back? Talking about 2001. Okay, 22 years back. This. I'm just taking this book, going through each line, trying to understand which book it is. Then this is a book by author Himal Anand. He says it's about field effect transistors. Okay, now the gate is like, how you control the tap, the water, how the water is controlled by your movement on the, with the tap, right? So now I understood, okay, this guy relates to me. Something is understandable. Then I got that book, read it. I mean, we just need a starting point. That's what I'm saying. Just an inspiration. So that book was an inspiration for me. I didn't mean to say I read everything from that book only, but I got an inspiration. I understood. Once I understood that, everything else was better. Then I started teaching my friends. My best way is the moment I learn it, for me to master it, I will teach. So I used to teach my friends in my college too. Long story short, in that semester, I got 10 CGPA in that subject. Clear, guys? And same has been all the 4 years. All these professors are great professors. They have publications and all that. But what they teach doesn't enter our brain. Okay. So all that I wanted to say was right, guys. I'm really, really sorry for overshooting. Well, because success is important for you guys. So you take 100% responsibility. I'm 100% responsible for my success. When you see that, what happens is your upset comes down. Of course, it is probably all that you say is valid. Okay, but take 100% responsibility for your actions and also for your success. You are responsible. The moment you feel that, right, then what happens? Nothing else matters. Somebody doesn't teach well, doesn't matter. Some book is not okay, doesn't matter. Tomorrow there's an assignment, doesn't matter. Tomorrow the test, doesn't matter. You're responsible for everything. All right. So this, it's not a burden or anything. It is a way of being. Okay, I'll probably in another opportunity, I would like to share with you guys. Being responsible. That keeps you cool. Okay, that keeps you cool amid situations which are not necessarily very comfortable or as expected. So this is one aspect I wanted to share with you. You're 100% responsible for your success and nobody to blame. When you feel 100% responsible, nobody to blame. You are the captain of the ship, of your ship. Correct. So it puts us in peace, first of all. We don't, complaining goes off, condemning goes off, criticizing goes off. What is left? Right? What is left is beautiful, your creativity, your creation. You will figure out a way. Your brain is super capable. This math, this physics, this chemistry, biology is no big deal, guys. Your brain is supremely capable. It can hold concepts of entire library in your head, okay? And all innovations, everything comes from here, guys. And when you're at peace, when you're at, when you're equanimous, able to take ups and downs, you understand the lecture, fantastic. You don't understand the lecture, okay, no problem. I'm still responsible. I will figure out a way. That attitude, I request you. I know it is asking probably for too much at this point, but I invite you to consider this approach. Despite all your points being valid, okay, it doesn't mean you should accept everything and not raise your points. No, nothing like that. Even raising your point can come out of your responsibility. That's what I'm saying. Oh, I am responsible for my, future. So if my conversation to this person may help me resolve this, you should converse and get it resolved. Okay, if it could be resolved. All right, students. Okay, this is what I wanted to share with you. All of you are wonderful students, and everybody is unique, and you are super powerful. Your brain is super powerful. If you believe that this subject is tough, that subject is tough, I don't understand this. All this is temporary. You put in efforts, be committed. For a committed person, there is no failure. For a committed person, there is no failure. Okay. All the best, students. Take care. Good night.